Hey, good morning, coffee lovers. It's great to have you all tuned in to a second Red Hat open source Espresso series. So my name is Janina. I'm a DevX specialist at Red Hat and also co-founder of the Dev Confederation, which is a cozy Swiss conference around developer experience and platform engineering. And with us today is Master Brewer Kevin. Kevin, tell us shortly who you are.
Hi, yeah, I'm Kevin Dubois. I'm a developer advocate, kind of floating between Red Hat and IBM these days. Yeah, so my core focuses on the developer experience. Making developers happy is how we often describe our role. And yeah, so my background is in software engineering. I've been doing that for over 20 years, and kind of again floating between software engineering and platform engineering and everything in between. So yeah, just
All right.
having fun, I guess.
Awesome. Great to have you here. So today we spent, again, no more than 15 minutes on a featured topic, and that's the forking tax and why we never maintain proprietary forks. So lean back, enjoy your ristretto, and I'll shoot my first question to you, Kevin.
Awesome.
So when a developer is blocked by an upstream project, let's say whether it's a bug in a Kubernetes controller or, I don't know, like a missing feature in a runtime framework or just like a slow PR review, I mean, the easiest thing in the world to do is just hit that, fork button on GitHub, fix it locally and ship it to production. It feels like this, instant win. Now, from a pure developer workflow perspective, why is that initial instant win of a local fork actually a honeypot trap? I mean, if we think 6 months down the line, what happens to the developer experience when that upstream project releases a major update?
Yeah, exactly. Yeah, it's a really good question, right? Because like you said, there's just a quick fix here or there, and I'm just going to fork it, and that way our business, our stakeholders are happy because we can ship this feature as quickly as possible. And sometimes we do have that pressure on us of, we need to deliver this thing. But then, like you said, a couple of weeks later, especially if it's 6 months later, there's a brand new feature in the upstream project, in this open source community project. And then what do we do? Because now we've created a fork and we've been working on this fork, which means that we've probably been committing and changing things in this fork in the meantime. And now we need to get this new feature into our fork, and actually it's completely diverged. And I mean, I've seen this in my career. I think many of my fellow developers have seen this too. And it becomes quite painful to then kind of get back to how do we get this back into our fork? And there's maybe two paths, right? There's one that's, well, we're just going to kind of try to manually bring it into our project. And then we need to continue maintaining that as we keep going. So that means that next time there's another feature, it's going to be even more work because we've diverged even more. So that's one solution. And especially these days with AI and code assistants, that's kind of tempting, right? Because you're like, hey, Claude, Bob, whatever your assistant is, bring this feature into my code, and your code assistant will be like, sure, I can do that. And it'll start kind of making these changes, but most likely, because it's not deterministic, it'll kind of pick and choose and try to fit that into your system. And then you have even less control over everything, making it even worse. On the other hand, the other kind of extreme is, okay, we need to get back to the baseline. We need to get back to where we were upstream, discard everything we've done over the last 6 months, and then reapply everything that we've done on top of, again, the community version, which in the long term is probably the best option if you find yourself in that spot. But regardless, it's a ton of work. Whereas at the start you were like, it's just quick little feature change, and we'll just maintain that fork. But after a while, it becomes more and more painful and costly too. Yeah.
Mm-hmm. You say it's a ton of work. Can you be more specific? I mean, in terms of day-to-day engineering labor, what does that forking tax actually look like? How much engineering time gets stolen by continually, rebasing and maintaining proprietary patches?
Yeah, I mean, depending on the project, right? If it's a small little project and maybe it starts out that way and then grows into something, but it can take up, eventually it can take up almost all the time of your engineering space. So then the question becomes, do we just completely diverge from the community project, from the open source upstream project, and just do our own thing, and we'll just kind of engineer everything ourselves, and we're going to completely duplicate all the work that other people are already doing upstream? Or like, what do we do? Do we continue to work and try to keep matching what there's in the community and try to merge it into into our code? It becomes quite difficult. And so, I mean, I've been in that situation in the past. And a lot of organizations are like that, where they're using open source projects, but their particular solution is maybe something that builds on top of that, but is not an open source project. Unfortunately, a lot of organizations are like that. They're not open source. That's really nice about working at Red Hat, is that we do get to do that. But yeah, I've seen this, firsthand, where our business, our product team asks us to add new features, and we're like, well, okay, but we need to maintain everything that's already there, and it ends up taking so much time that we're struggling to bring any new features in anymore. So it's quite painful. I mean, if you maybe taking like Java as an example, there's a lot of organizations that are still on Java 8, kind of in a similar situation, because to bring everything up to date with Java 25, 26 these days, it requires so much work to be able to do that. The risk assessments that come with that, there's all the engineering efforts of updating everything, even though technically Java is fully backwards compatible, but there's a lot of that needs to be done. Whereas if we keep that kind of upstream model the way that we do at Red Hat, it has a lot of advantages, right? So it means that we don't have to go back and try to fit things back into what we're doing. We can actually move forward, and when we contribute upstream, then we can consume that downstream, and we can actually keep developing in kind of a streamlined way that's not kind of going backwards every time. We can always just go forward with features. Even if we need to fix anything, we go upstream first and then can do that. So yeah, I mean, so going back to that question of how much time actually gets stolen, it's crazy amounts. I was reading this report too. I have it here on the side, so I have the actual number. But there was an OpenSSF report, and they found that organizations maintaining private forks of upstream projects spend approximately $258,000 in labor costs per release cycle. So that's quite a bit of money, just kind of because maintaining those private forks, right? So
certainly is. All right. Fair. Now, you mentioned Red Hat, and well, Red Hat is all open source, right? We have a strict internal engineering policy which says if a feature or patch doesn't get accepted by the upstream community, we actually refuse to carry it as a product-only feature. Now, to marketing people, that sounds like we are, intentionally slowing ourselves down. Now, you elaborate a little bit on that already, but I'm still curious. You work with communities like Quarkus and Kubernetes. So when a massive enterprise customer now just comes to you and say, hey, we want this niche feature immediately, how do you explain like the architectural necessity of saying, hey, no, we are going to fight to get this into the core project first, even if it takes months? I mean, that must be quite a stretch.
It's tricky. And I've been in that situation as a solution architect at Red Hat. We were working with a major customer. This was in Belgium, and they wanted a feature where they wanted pods to basically the resource size being resized without restarting the pod. And this is something that was not possible. And they wanted that specifically because they were working with Spring Boot projects, and they use a lot of resources during startup. And then once the application has started up, the resource usage becomes a lot less, but they have to reserve all that space for those pods just because of the startup time. And so they asked, like, hey, it would be cool if we could, kind of on the fly change the resources or the limits of the pods. And how do we do that? And we had to tell them, well, right now you can't in Kubernetes. And right now, I mean in the past. And so they said, okay, can we do an RFE, or request for enhancement for that feature? We said, sure. And so we could have gone in the direction of, we'll apply that directly into OpenShift, and the customer would have been happy because it would be immediately there. But we did have to tell them that no, sorry, we have to get buy-in from the community first, because we want to make sure that this is done in a way that works for everyone, not just for this particular customer in this particular way that we're thinking of, because maybe there's other contributors to Kubernetes that might have a different view. And in fact, it was quite a process to get this feature in upstream Kubernetes. And then finally in OpenShift, it took actually a couple of years. And so, yeah. So,
you're kind
so
of
how do you
floating
explain that?
also. Sorry to interrupt you there. You're kind of floating also between, upstream, or kind of the upstream communities and customer expectations, right? It's always a constant back and forth.
Yes.
Understood. I have so many more questions, but we also got some questions from the audience. So let's have a look at those, shall we?
Okay. All right. Let's hear it.
And here we have a first question. So that's a very interesting one. And it seems it's from a team that is actually struggling with that forking tax. And they are saying, hey, our engineering team is currently drowning in this exact forking tax, because we modified a few public open source dependencies a while ago to unblock ourselves. But now, how do we even start digging ourselves out of this debt and kind of pushing our changes back upstream without breaking our current production stack? Ooh, you have some experience with that.
Yeah, that's, I mean, that's where a lot of us end up at some point, right? And like the short answer is it depends, of course, like everything. But yeah, I mean, the way that I would tackle that is, first you would, of course, do a pretty thorough analysis of what exactly has diverged between the different projects, right? What is upstream, what has been added in upstream, and what has been added in your fork. And then you can do an analysis of that. Fortunately, with AI these days, you can do that pretty, let's say, fairly easily, right? You can ask your chat assistant to do an analysis and compare the fork and then see what's happening. And then when you have that analysis, you're going to have to make kind of maybe a hard decision, which is to stop making additional changes in your own fork while you try to get back to the upstream. And that's a challenge, because you have new features that need to be shipped.
Sure.
But yeah, that's kind of a little bit of the pain. And then you need to make some architectural decisions of what has priority of features that you have in your fork that you would want to have in the upstream project, or at least in the project that you're having. So you have to kind of prioritize what's going to be the most important, what do we really want to focus on, and then try to start contributing those features to the upstream project if possible, which means that you're going to need to defend why everybody should be interested in that feature and not just you, right? Because that's kind of the power of open source, is that it's there, a collaboration between different organizations, between different users, and we choose what makes the most sense for everybody. And then, so expect some discussions about that. That's also part of open source is some vivid discussions sometimes, so maybe some pushback. And then, but yeah, and then once that gets accepted upstream, then, you're also part of the innovation of something greater. And I think one key thing to keep in mind too is that if you do end up contributing to that upstream project, you also have to be prepared that other vendors and maybe your competitors are going to use that feature as well. But yeah, that's how we work at Red Hat too. At the end of the day, there's a lot of work that we do that our competitors also get to benefit from, but it's vice versa too, right? We get to benefit from what they're doing, and at the end of the day, as a community, we're going faster forward and have more innovation. So I mean, I think
Sharing is
that's a real
caring.
path. Yeah. Of course, yeah, you have to be prepared for, some features you probably don't want to have in upstream, but I would say go back to that upstream and then, maybe work from there and try to keep that upstream spirit alive.
Ooh, that's a challenge there. Okay,
Yeah.
hey, thank you very much. We're already at the end of the time. This is a super short format, as like a million questions left. So I do hope we can still address them somewhere in the future. Thanks everyone for joining. Thank you very much, Kevin. And everyone make sure to dial in next week as well. And this will be all about AI, weights and measures. Have a very nice day.
Thank you.